This video provides an overview of how to configure and use the PowerMonitor 5000 Power Quality and Energy Monitoring Advanced Faceplates from Rockwell Automation's Power Device Library. These HMI faceplate displays are available exclusively for FactoryTalk Optix and allow you to view detailed information from live data dashboards to harmonics, alarm and event logs, and power quality events. You can also configure subscriptions to email notifications for power quality events. These functions can be used with the PowerMonitor 5000. However, there may be different levels of functionality depending on the specific model, from the base M5E model up to the most feature-rich M8E model. Let's take a look at how to get started. Before you begin, if you haven't already done so, run the setup command script provided in the root folder of the library. This will register the library in FactoryTalk Optix by copying it to the default location. Now open up a project in FactoryTalk Optix where you would like to connect the PowerMonitor. Click on the library icon in the toolbar to view the available libraries. Find the Power Device V4 library or use the search bar to find the PM5000 PQEM objects. First, drag the PQEM model folder into your project's model folder, then drag the PQEM UI folder into your project's UI folder. We recommend organizing the UI folder to include a folder for Rockwell Automation libraries, and you might even want subfolders for specific libraries like Power Device if you plan on using more library objects. We also recommend that you use the standard ISA 101 style sheets. While the library viewer is open, search for Style Sheet or browse the Style Sheets folder and find the ISA style sheet. Drag this into your project's UI folder. Then to assign this style sheet, click on the native presentation engine and link the style sheet reference to the newly added style sheet. This will ensure a consistent look and feel with the standard grayscale high-performance HMI design. You may have noticed a NetLogic error when you imported the model and the solution failed to build. You need to fix this issue by updating a project reference. Open the project's file folder in Windows. You can get there easily by clicking the project file folder in the toolbar. Then again, clicking the folder icon to open the location in Windows. Then navigate to the Net Solution folder. Find the project file with the CS project extension and open it in a simple text editor like Notepad. Directly before the final line, you will need to paste the item group section shown here. You can easily copy this either from the library object's description or from the library's reference manual. Save the file and you should see the project compile back in Optix. If you plan on using email notifications for power quality events, follow these next steps. First, expand the PQEM model folder and find the Setup NetLogic object. Right-click and run the initial setup method. Next, select the Email General Settings model. This includes all of the global email notification settings. In the Properties window, enter the required information based on your SMTP email server and sender address information. You may need to work with your IT team for some of these settings. Now you need to link to specific PowerMonitor devices. Right-click on the model and select New. Then navigate to the PQEM folder and select the PQEM model. This creates a unique instance of the PowerMonitor model. Rename the model to something that represents your application, such as the area of your facility that is being monitored. Now with the new model instance selected, move to the Properties window. Assign the IP address of the PowerMonitor device. This should be on the same network as Optix, and does not allow for backplane bridging through a Logix controller. All of the other parameters are optional and can be left as default. You can configure the update period for checking for new power quality events and the live data update rate as well. You can also assign a username and password if security is enabled on your PowerMonitor. The last step is creating a graphic symbol on a screen which will be used as a launch button to open the faceplate. Go to a screen or window of your choice in your project. There are a couple ways to create a new graphic symbol. One way is to right-click the target container in the project view. Select New and navigate through your UI organization to the location you stored the PQEM folder. In the Graphics Symbols folder, there are two options, either a regular graphics symbol, which looks like the device, or a horizontal version, which can be used to create a list. Select the one that suits your needs. The alternative method is to use the Type View window to navigate to these graphics symbol objects, then drag and drop the symbol onto the screen. Now with the new graphics symbol selected, view the Properties window. Link the ref tag property to the model instance you previously created. You can repeat these steps for as many PowerMonitor devices on your network that you would like to connect to. The configuration is now complete and you can test or run your application. The first time the project runs, it creates and initializes database dependencies for power quality events. So you will need to restart the application again in order to view power quality events and the ITI and SEMI F47 charts. With your application running, first you will notice that the graphics symbol has some basic information like the fault status, and the horizontal symbol option includes some key metering values. Clicking the symbol will open the faceplate. At the top of each tab, there is a banner which displays the device status. Ready means that it is connected and communicating. Not ready displays a connection fault. The IP address is displayed here as well. There is a drop-down menu to see any active alarms. Tab navigation is on the left, and we will now walk through each tab of the faceplate. The initial page, or Home tab, displays the real-time power quality dashboard, including key metrics and power factor information. You can change the information displayed on the chart from either voltages, currents, power, or frequency data. The second tab is the Live Energy and Demand dashboard. Here you will find energy information like the forward and net energy, demand and projected demand values, and apparent energy and amp hours. The Harmonics tab allows you to use the drop-down menus to select the harmonic group and the range or number of harmonics displayed. Use the Show or Hide Fundamental button to toggle between displaying the first harmonic or DC value. View either a bar or line graph and see the list of values on the left. The Wiring Diagnostics dashboard includes wiring test results, a phasor diagram, and wiring connection status. Note that wiring tests must be initiated from the device's web page and cannot be run from the faceplate. The ITI and SEMI F47 chart displays a prohibited region, no interruption in function region, and no damage region. Triangles are plotted on the chart for each relevant power quality event captured within the selected time range. You can use the time range selector in the bottom right of the display to change the event range. The Power Quality Logs tab includes a list of power quality events, including an event category, total number of event occurrences, latest occurrence, timestamp, and trend. Each category includes a view button which brings you to a table at the bottom displaying each occurrence within the category. Also included are charts for event frequency over time, event duration analysis, voltage levels, and an event types distribution pie chart. A time range selector is provided in the bottom right to filter the event window. The Logs tab contains a number of sub-tabs including data logs, events, alarms, min-max, setpoint logs, time of use logs, and energy logs. Use the tabs across the top to navigate to each area. Note that for each log, it may take a moment to download the data, so please be patient while it loads. A status message and refresh button is provided in the bottom right corner. The Data Logs tab includes a list of available datalog CSV files, each with a timestamp included in the file name. Click on the file to view the data. The event log includes a count of each event type and a timestamp log. Similarly, the alarm log includes a count per alarm type and a timestamp log. The min-max log displays ranges for voltage, current, power, and phase readings since the last reset. A log of each minimum or maximum reading is displayed below the chart. These values can be reset from the PowerMonitor's webpage. The setpoint logs includes a timestamp log of all setpoint status changes. The time of use log includes various usage over time charts. A timestamp log is included at the bottom of the page. The final log is the energy log. This provides a list of energy log CSV files with a timestamp. Clicking on any row will load the detailed log and a graph of kilowatts demand and net gigawatt hours. Now moving on to the Email Configuration tab. This is used to configure and monitor email settings for any PowerMonitor 5000 device configured. Note that although this tab is shown on a specific device's faceplate, the settings are global to all devices. There are 3 sub-tabs. The User Settings sub-tab allows you to manage users for email notifications. You can add and modify users, including a name and email address. Each user can be enabled or disabled using the toggle button. Each user can also subscribe to specific event types, such as voltage swell, and this is applied to all power monitors that are configured. The Device Settings sub-tab includes useful information about the power monitor device, including its name, IP address, location, catalog number, MAC or Ethernet address, hardware revision, and firmware revision. The Email Logs sub-tab includes a history of any emails delivered. Next, the Waveform Viewer tab allows you to view detailed high-speed waveforms associated with certain power quality events where waveforms are captured. Select the desired waveform from the file list and wait for the waveform to load. This may take a moment and a cancel button is provided. Note that in some cases, while a download occurs, you may experience a temporary device connection fault. This is normal. Use the legend to toggle visibility for phase voltages or current pens, and use the slide below the graph to zoom into specific areas. The Faceplate's final tab is the Alarms tab. This display groups alarms into various categories. Expand a group's accordion to see details of each alarm's status. Active alarms are shown in blue. An alarm icon is displayed in the header for a category which contains any active alarm. Remember, you can also see a summarized list of active alarms at any time from the drop-down in the top toolbar. This concludes the overview video for configuring and using the Power Device Library's PowerMonitor 5000 Advanced Power Quality and Energy Monitoring Faceplates. All of Rockwell Automation's device libraries can be downloaded for free from our website in the Product Download Center. Just search Device Library.